Hello, everyone. In previous sessions, we cover how does large language model work in general and its tokenization process. In this session, we will focus on inference. Okay, like we mentioned before, this inference process will just mainly involve taking users' input prompt, um, and then that will become a tokens, and then process them sequentially through the model's parameters. All right, it will generate the output tokens, basically, right? In these sessions, we will just look at how GPT-2 model, especially GPT-2 small, do this inference process from the source code level. All right. Um, we will just open the code base and see how does it work end to end. But before we do that, let's quickly do a recap on the GPT-2 architecture. It's just multiple layers of transformer blocks. If you look at this one, you will see from the input, they do the encoding, including positional encoding, and then it runs through multiple layers of transformer blocks, and then in the end, they give you the output to get the token. There's a better way to visualize this one. It's in this LLM visualization web page. You can already see in this place, you see this nano GPT. It only has 85,000 parameters, but if you see the individual layer, it's quite huge. It only has 3 transformers. Compared with GPT-2 small, it has basically 12 layers, 12 transformers. And then if you comparing which has 124 million parameters, if you compare with the same series with extra large, this is 1.5 billion. And obviously for GPT-3, this is massive and huge, which have this amount of parameters, right? So again, all these GPT models, they follow the same like the architectural format with multiple layers of transformers. And in the transformers, it will also have other things like the self-attention block and multi-layer perceptron and this layer normalization. All right, we could cover them in detail in the code. All right, so if you ever want to like read in detail about how does individual section work, I recommend you to look at this page from Jay, the illustrated GPT-2. One thing to quickly mention is like at the end of the section 2, it kind of give us a really great breakdown of how does all the 124 million parameters are distributed across multiple layers, right? Based on the how many blocks and how many parameters are used at the individual component level, which is very fun and interesting to read it through. But let's quickly, I think we can quickly jump back to the code level. I have already downloaded the code. It's in my VS Code, and let's just quickly go through the code base together. All right. To start with, you need to download your model. Depends on the size. I only download the smallest one, which is I just run this one. Obviously, you still need to install your virtual environment variable to make it working end to end. You can download this one. It will download these couple of files. You can probably guess what does this mean based on the name, right? For example, the hyperparameters I have downloaded. Let's open it. Hyperparameters just what's the vocabulary size, context length, embedding dimensions, and how many headers, like multi-header attention, how many headers each layer and how many layers. All right. You will also see this encoder, which is pretty much the vocabulary list from 0 to this special token, right? That's 50, 50K like vocabulary list, and also this BPE file, which is also the used in the tokenization process. You will also see many checkpoint files, right? These checkpoint files. These are pretty much just the parameters. But why they are called checkpoint is because during the training process, normally what engineers want to do is have this ability to pause and resume later. So after they're doing the training process, after multiple iterations, after certain steps, they will save all the existing trained parameter into a checkpoint file. right? So at the end of the training process, you will have multiple checkpoint, like a snapshot for your existing training parameters. So just consider this checkpoint as your model parameters. Okay. Obviously, um, obviously we have already covered the parameter distribution is pretty much over here. Yeah, let's quickly come back to the source code. Once we have everything, we can start running it, right? Before we run it, let's look at what's in it. Right. First of all, there are a couple of files in the source code. Let's go through them step by step. So first of all, this encoder, as you can imagine from the description, is just the main tokenization process, right? In this tokenization process, it has lots of method and functions, helper functions, but the main one is this class. It has this encoder class, and then it has this BP method. We don't have to go deep into what does it do very detailed, but we can see this encode and decode. It just convert the token into token ID, and decode is take the token and then return it back to the text. All right. Finally, we have this get encoder. This method will actually be used in the main entry point of the code, and then you will see you will just load these two files and then return this encoder instance. All right. Next one is this hyperparameters. As you can imagine, it's just read from these hyperparameters. And then next one we can see is this model. Okay. This model file is pretty much the key transformer architecture. All right. So the full implementation has lived in this file. You can already I guess you can already see many names you can probably recognize, like softmax, this activation function, this layer normalization, this is reshape and merge, and this is the conv1d, and also attention mask, attention layer. You have many detailed implementation in the attention layer, like multi-head attention and mask attention weights, and so on and so forth. And then they do lots of QKV, query and key and value. They do the manipulation and then do the calculation. And then you have this multi-layer perceptron, and then this block. This basically this individual block is a single layer of transformer block with both attention and multi-layer perceptron. Well, generally speaking, this multi-layer perceptron is also known as this feed-forward network, right? This kind of interchangeable when it comes to this neural network. And then you have blah 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 position for position encoding, and this one. Well, basically this model is the main entry point. As you can see, it does the encoding, including the positional encoding, and then it builds this transformer, and then it will just return the output logics, right? This output logics will then, like this mentioned, output logic will go to this linear normalization and this linear block, and then this softmax, and then you generate the output. All right. So the output is later sent to this sample file. This sample file, as you can see, top P, top K, this is top K, and this top P. You already see some familiar terminology you often use when you try to inference a model. Top P, top K, and I think we can also find temperature. The temperature over here. You can adjust it. You can adjust it over here. Okay, so this sample sequence will be the main place. It try to do the next token prediction, and it will later return you this token ID, I guess. And then that's the three key files: encoder and model and sample. All right. How does these all three being used in an end-to-end way? So there are two entry points in the inference. One is this generate unconditional samples. The other is interactive conditional samples. Let's look all of them. So for this one, as you can see from the description, it will just unconditional keep generating text based on the configuration parameters. It will just try to generate samples indefinitely, okay, and then based on these parameters, hyperparameters, you can obviously read it through, but at the higher level, you have your input, you do your encoding, and then this is your output sampling strategy, and then you create a TensorFlow session, and then you just start running it, and then you get the output, and then you decode it and you return, right? And then on the other side, you have this interactive conditioning, which is slightly better because you get to control what's being generated as an output. For example, the key difference here is to make it interactive, you have this process of input and token, and then it will return based on your input token. It will generate the output based on the token. Let's run them both. Let's first run the unconditional. For example, if I just run it with some parameters, I specify only generate one, otherwise it will indefinitely keep generating output. All right. Okay, ignore all the warnings. I start from over here. It's against school policy for us, blah, blah, blah. Well, you can see those are like proper English words, but might not make sense, right? Obviously, we also didn't give it a proper input prompt. That's why it looks so strange. Let's ignore this one. Let's focus on the other side. The interactive conditional samples. I specify the output maximum output token is 50. We can just run it. All right. So ignore all the warnings, and let's see what we can do with it, right? So we can try a couple of things. For example, a cat sat on a, let's see what's the output, on a bed at a suburban school in LA from blah blah blah. But later you see it kind of doesn't make sense anymore, right? That's why it makes sense to for us to reduce the output length to maybe to 10 if we want to have a basic interaction with it, right? Let's try it again. A cat sat on a bench. Okay. We can try another one. The future of AI is quickly developing for almost any topic. Okay, that's a very coherent and fluent English. Let's try it another time, because we didn't provide the seed, which is over here, right? Which this give us the this does not give us the deterministic result, so it's kind of very random. We can try multiple times. It would just give us different output. Which is very interesting, right? Which is the nature of this probability statistical system. Okay, let's run it a couple more times. Another thing I want to mention is, for example, let's try the capital of France is currently home to blah blah blah. Okay, try another time. Blah blah blah. It doesn't make sense, right? But still, even with this auto-complete system, like GPT-2, we can still do some prompting techniques. For example, we can do a multi-shot prompt. Capital of Australia is Canberra. Germany, Berlin. Capital of France is, doesn't make sense. Let's see if we try a couple times. Okay, a city, but not actually the case. It just give us different city name, but not actually the correct one, right? This also prove that this model actually just try to mimic the output based on input, but actually does not know what actually is generating. And very likely, after certain iteration, after going through this end-to-end process, it kind of lost track and doesn't understand it exactly what does it mean. All right, I will stop over here, and thanks for watching.